To solve this problem, we will use substitution method. So I will put u is equal 3x squared. Now we have to find the derivative of both sides of our equation with respect to x. So du to dx is equal, derivative of 3x squared is 6x. We need to find du. It means I have to multiply both sides by dx. dx and dx we reduce now. And we have du is equal 6x dx. Let me rewrite our indefinite integral. I can put first secant of 3x squared and next times x, and we have dx. We found that du is equal 6x dx. We have only x dx here, because when we substitute 3x squared by u, we will have secant u and x dx. We cannot mix x and u in one expression. So we need to substitute x dx. So it means I will divide both sides of our equation, because we have multiplication here, by 6. And I can reduce 6 and 6 now. So we have now x dx is equal, I can write 1 over 6 du. So our indefinite integral we can rewrite now, and we will have secant of u, and x dx is 1 over 6. We can put in parentheses du. When we have multiplication and we have constant, we can take this constant before indefinite integral symbol. So we have 1 over 6 indefinite integral of secant of u du. We know that indefinite integral of secant u with respect to u is natural logarithm of absolute value of secant u plus tangent u. So we can rewrite our 1 over 6, and we have times, I can put in parentheses, it will be natural logarithm of absolute value of secant of u plus tangent of u, and of course plus constant number. This is equal. When we multiply constant by constant, we still will have constant. So I don't have to put 1 over 6 times c. So let me rewrite this. We will have 1 over 6 natural logarithm of secant of u plus tangent of u plus constant. We can put, if you want, c1. Now we have to come back to our substitution. U is equal 3x squared. So we have natural logarithm of absolute value of secant of 3x squared plus tangent of 3x squared, of course absolute value, plus constant c1. This is my solution.